Hello everyone. In our today's problem, we have to find lexigraphically small string after applying operations. This question is one of my favorite questions. So you will be given a string as of even length. So the length is even, and also you will be and consisting digits 0 to 9. So each digit will be 0 to 9. Okay. Also, you will be given two integers a and b. Now you can perform two operation as much as time you want. Like, so one operation is add a to all um odd indices. Okay, so this is one. Second one is rotate a string right by p position. Okay, so if I explain it to you, like, so you'll be given a string with even numbers. Okay, and each number will be 0 to 9. That's one. Okay. Now you can perform two operation. One is uh, one is add a through the all odd, was it all? Yeah, odd indices. Okay. And another one is move the string to B position. Okay. So if the string is 5525, okay, and if you want to add a, which is equal to 9, to all odd indices, so 0, the first index is 0, then 1, then 2, then 3. So all index will be 1 and 3. So we can add 9 here. Now here is the catch. Catch means here is another rules. Like, digit post 9 are cycled back 0. Okay. Now, if you add 9 to 5 with 5, which will be 5 plus 9, which will be 14. So, the number we can add is 4. Okay. So, it will come back to 0 again when it passed 10. Okay. So, the answer will be the first index will be 5, then the second index, which is index number 1, will be 5 plus 9, which is 14, and we will take the last number, which is 4. Okay, 2 will be remain same. Again, 5 plus 9, which will be 4. Okay, again you can keep adding and adding. Then the second option is you can move the index two position. So if we move the two position means these two will come forward. Okay, so 2, 4, 5, 4. I will get it. Like if the string is 1, 2, 3, 4, 5, 6, and I say I'll move 4 position to the right. So this 4 position will come forward. So 3, 4, 5, 6, and then 1, 2. I hope you got it right. Now that's done. So you have to perform this two operation as much as time you want, and all you have to find lexicographically smallest string. So like uh I know, yeah, I hope you know what that means. Like lexicographically smallest string is the smallest number here. Okay, so if you have a look at the constraints, the length will be 100, length will be always even, digit 0 to 9, and A will be less 1 to 9, B will be like maximum of length minus 1. Okay, so as long as the length is 100, we can use brute force approach here. Okay, so here what we can do, we can explore all of the numbers we can generate from this string, and then each and every time we'll keep tracking the smallest number, and at the end, once we generate all the numbers, we'll return the smallest number. Okay, so the maximum number we can generate is 10 into 10, as the it will be 10 and 10 into 10 and into as length. Okay, as length. That kind of number we can generate, and as the length will be maximum and 1000 or what was it? 1000 or 100. So we can generate maximum this much of test case, this much of number. Okay. So what we can do is like we'll be performing rotation and changing position at the same time, and at the same time we'll be keep tracking on the smallest number. So what I'll do, I'll say um, length. So and as this to prevent generating the same number two times, what we can do, we'll keep track the visited number. So I'll say unordered set, which will be string, and I can say visited. Also, we will be taking a queue string queue, and then I will be keep tracking the smallest number. Smallest will be s at the beginning, and then visited dot queue visited insert will be current string, which will be visited, and queue dot push will be current string. Okay. And at the end, I'll be return the smallest. That's it. And what I'll be doing, I'll be checking while queue is not empty. Um, I'll be saying string here will be queue dot front. Yeah, front. It should be front and queue dot pop. That's it. Then I'll be keep comparing the smallest one. Smallest will be a minimum of smallest or my current string. Is it? No, I'll be saying my string. So our first operation we can add a. Okay, so added string will be string, and if I add, okay, so as this is on string format, what we can do, for example, you want to, okay, it's 1, 2, 3, or 5, 4, 4, 4, and you want to add 9 here with the 4. Okay, so and A is on integer format. So what we can do, we can convert this 4 to integer. So what you can do, 4 plus it will be minus 4 minus 0 string, which will be 4. Then add 9, which will be 13. 10 divided by 10 and take the remainder. So it will be 3. And again, plus 0, string 0, which will be then 3 again, and we can push it back. Yeah, we can do like this. So what we will be doing, and we'll be running a loop, right? So for int I equal to, I'll start from index number 1, I less than edit string dot size I plus equal to 2, as I'll be going through all odd index, and here I can say edit string of I will be I'll be keep adding the 0, and here I'll be taking off the 0 from header string of I'll be making the string, I'll be converting the string to a number. Then I'm adding the current number A, and at the end I'm taking the mod of 10. Yeah, that's it. Okay. And then we can say, is it visited or not? Okay, so if not visited dot count of my added string to visited dot insert added string and push it to the queue. So queue dot push added string. That's it. So that is one added string. Then I will be comparing with the uh, rotated one. So rotated rotated string. So for rotating string, it's pretty much simple. Like for example, it is 5, 2, 3, 4. Okay, and 5, 2, 3, 4, 5, 2, 3, 4, 6. Okay. Now if you wanna rotate 3 position to the right, so the 3 position will come forward, right? So what we can do, we can take a substring. The length is 5. Okay, the length is 5. The length is 5, and position I want is 3. So 5 minus 3, which will be 2. So what we can do, we can take after my second index, so this one, we can take this one forward. So substring of size minus p, this one equal to 346 plus substring of from 0 till again size minus b, which will be 0 to 2, and which will be 5 2. So plus 5 2, and answer will be 346 plus 5 2. Okay, 346 5 2. So all of them are string. That's okay. So that's how we can like change the position. So so the string, string dot substring. Yeah. So what I'll do, string dot size minus p. Then again, string dot substring from 0 to again string dot size minus p. That's it. And for this, I'll be again checking the is it visited or not. I think we can make a separate function for visited one. So what I'll be doing, I'll just cut this, and I'll be saying here repeat private void, okay, void is visited, and string 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 and if visited, so it will be string, then return push, and then here I also can say is visited added string Also, here I can say is visited rooted string, and as I am doing visited and queue here, so I have to take them out and put them here. Okay, this here. So visited here, queue here, and I'm checking is visited, and at the same time, if it is not visited, I'm pushing it to the queue and to the visited set. Yeah, that's it. If I run it, oh, string, why did I put queue? I got so many spelling mistake. Okay, hopefully it will be fine. And yeah, I successfully passed the test case. If I submit this one, it is accepted, guys. Thank you so much.